We're going to do 5C notes. We're going to split this probably into 3 parts, and one of the parts is me, just like in A and B, just a graphing one showing you how to do it in MyLabs Plus. This time what we're going to do, it's called systems of equations. Basically, that means we're going to have 2 equations, and we're going to find solutions to both of them. At least we're hoping to find both. But if it has at least one solution, it's called consistent. If they are parallel lines, it's called inconsistent. Now, inconsistent lines give us no equation or no solutions. That's why they're parallel, because they never intersect. If a system of infinitely many solutions, they're called dependent. Basically, they're the same line. And if you see 2 separate lines, it's independent. Now, I know that was very confusing, and we're going to do a bunch of graphs, and I'm going to explain it better. We're going to use the way to graph like we did in 5B by just using the slope and intercept. This first one I like to do because it gets a little confusing because when we look at what's the y-intercept, there's nothing being added to negative 2x. And I would have to say exactly, because I'm really adding 0, aren't I? And if I put this over 1, now I know my slope is negative 2 over 1, and my y-intercept is 0. So I go to where the y-intercept is 0, plot my first point. I go down 2 and over 1, down 2 over 1. And if we think about this, the slope is negative 2 over 1, but if I were to write positive 2 over negative 1, that's also negative 2. And the reason why I'm saying this, because if I go up 2, 1, 2, and then go backwards 1, I'm still in the same line, aren't I? Sometimes we have to do it. I didn't have to do it here, but I'm trying to obviously plan for the future here. We have y equals 3x plus 5. So my slope is going to be 3 over 1, and my y-intercept is equal to 5. I'm going to draw this in a different color. I'm going to go up 5 for the y-intercept. 1, 2, 3, 4, 5. Now if I go up 3, 1, 2, 3 over 1, I'm way off the graph, aren't I? But remember, I can make this negative 3 and negative 1. Negative over negative is still positive, so I can go down 3, 1, 2, 3, and backwards 1. And you can see I have my intersection, don't I? This is my answer. My x value is negative 1, my y value is 2. So my answer is negative 1, comma 2. Now, this has at least one solution, so it is consistent. And really, I try to remember, inconsistent lines are parallel lines. Clearly, these 2 lines are not parallel, so it's got to be consistent. If they're the same line, now the same line means they're right on top of each other. There's definitely 2 different lines, so they are independent. And that will be my answer. When I do the graphing, how to use the MyLabs Plus, you'll see you'll just have to, there'll be little dots here or open circles where you check off what the correct ones are. Now this next one, there's a little more work involved here because I have to solve for y this time for both equations. Now the first one's pretty easy. If I have 4x plus y equals 5, I just subtract 4x. And my first graph is negative 4x plus 5. My next one is not as simple. 3x minus 2y equals 12. I'm going to subtract 3x from each side, so I get negative 2y equals negative 3x plus 12. I'm going to divide everything by negative 2, and then I get y equals 3 halves x minus 6. So here is one of my graphs, and here was the other graph. So y equals negative 4x plus 5. So I'm going to go up 5, 1, 2, 3, 4, 5, plot on the y-axis. Remember, my slope here is negative 4 over 1, so I'm going to go down 4, 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Now remember, when you're on the computer, you just go down 4 over once, and it draws the perfect line for you. y equals 3 halves x minus 6. So I'll do this in the other color, red. My y-intercept is negative 6. I'm going to go down 6. 1, 2, 3, 4, 5, 6. I'm going to go up 3. 1, 2, 3 over 2. And there's my intercept right there. So my intercept this time, well, x is 2 there, and y is negative 3, so it's 2, negative 3. So I have, remember, inconsistent are parallel. These are certainly not parallel, so they have to be consistent. And these are not parallel lines. I mean, they're not on top of each other, so they are two independent lines. All right, I got two more graphs to do. So if I let y minus 2x, if I solve for y minus 2x equals 6, I have to add 2x over. So I get y equals 2x plus 6. My other equation is a little harder. I have fractions involved. But I still got to get y by itself, so I got to add the 3 over. So I get 1 half y equals x plus 3. Now remember, to get rid of this, we divide by what's attached to it. So we divide everything by a half. And then we get y equals 2x plus 6. Now if you notice, they are the same line, aren't they? So if I were to graph this up, go up to 6. Now I can't go up, so I got to go back down 2, backwards 1. That's my first line. If I draw my other line, it's right on top of the other line. So, and remember, inconsistent are parallel. You'll see two parallel lines. I don't see two parallel lines, so it's still consistent because I'm getting an answer. But they are now considered dependent because they're the same line. I do not see two independent lines. So when I only see one line on the graph, it is dependent. So when I do my next one here, you can almost guess what's going to happen here. If I do 2y plus x equals 6, subtract the x over, I get 2y equals negative x plus 6. Divide everything by 2, I get y equals negative 1 half x plus 3. My other equation is 1 half x plus y equals 4. I'm going to subtract 1 half x over, so I'm going to get y equals negative 1 half x plus 4. So I have to graph these two lines. And if you notice, they have the same slope, but different y-intercept. So if I graph the first one, 1, 2, 3, plot my point. My slope is negative 1 over 2, so I go down 1 over 2, down 1 over 2. Draw my line. Gonna do my other one in the other color. Negative 1 half x plus 4, so I go 1, 2, 3, 4, plot there. Down 1 over 2, down 1 over 2. Then I'm going to have another line. I know my lines aren't perfect here, but there are two parallel lines. And inconsistent is parallel lines. So I have a pair of inconsistent lines, and there's no solution to this because they never intersect. Okay, but I do see two separate lines, so they are independent. And like I said, when I do the MyLabs Plus video, you'll watch how to do this on the graph paper, practicing the slope and the intercept. That was using graphing to solve systems of equations. Now we're going to do some algebraic solutions to this. The first one we like to show is the substitution method. Now, we need to solve for one of the letters. Now, this could be x or y, it doesn't matter. In this first question, x is already solved for, so I am definitely going to be using that. What substitution means is, since x equals 3y plus 6, I'm going to take this 3y plus 6, and I'm going to substitute it in for x. So that means, instead of 4x, I'm going to write 4 times 3y plus 6 plus 3y equals 9. I'm going to distribute the 4 to each one, so it's 12y plus 24 plus 3y equals 9. I'm going to combine my like terms. 15y plus 24 equals 9. I have to subtract the 24 over to the other side, because remember, I'm moving the opposite side, do opposite sign. 15y equals negative 15. Divide each side by 15, I get y equals negative 1. So that's one of my solutions. So now my other one, I'm just going to use this original formula here. X equals, and I'm going to substitute again, 3 times negative 1 plus 6. I'm just using that equation, but I'm plugging in y equals negative 1. Negative 3 plus 6 is equal to 3. So x equals 3. And they're always going to want you to write this as a coordinate. So if x is 3, y is negative 1. And that's how I'm going to type in my answer. It's kind of the same thing we were doing earlier, except now we're doing algebraically. This next one here. I'm always looking for a variable with a coefficient of 1 on it, or really just a letter by itself. Clearly, the only one that's by itself is this y. I really don't want to solve for any of the other ones because they could bring in fractions. So if I want to solve for y here, I'm going to have to subtract the 3x over. And just out of habit, I'm going to write y equals negative 3x plus 4. But what I want to do is I'm going to take this y equals negative 3x plus 4, and I'm going to put it in to the y value. The last question, if you noticed, I took over here, when I had the x, I put it in for the x value. Here I'm solving for the y, so I'm going to put it in for the y value. So with that, I'm going to have 4x plus 2. Now instead of y, I know it's negative 3x plus 4 equals 4. Now I just have to do a little math work here, just like I did in Unit 4. Plus negative 6x plus 8 equals 4. 4x minus 6x is negative 2x plus 8 equals 4. I have to subtract 8. Negative 2x equals negative 4. Divide everything by negative 2. I get x equals 2. Now I have x equals 2, so now I need to substitute it in here to solve for y. Y equals negative 3 times 2 plus 4. Y is equal to negative 6 plus 4, which is equal to negative 2. So if y equals negative 2 and x equals 2, my answer is 2 comma negative 2. And there is a skill to pick the proper letter to solve for. If you pick the wrong one and you get terrible fractions, please stop and try to choose a different letter. Alrighty, and the last of the substitutions, we have 3x plus 6y equals 12. We have x plus 2y equals 7. Well, clearly that is my only single variable here, with the coefficient of 1. So I'm going to subtract my 2y over, and that is very weird solving for x, isn't it? We've always solved for y for the slope-intercept, but in substitution we could do either or. So I get x equals 7 minus 2y. So I've solved for x, so I want to put it in for my x. So it's 3 times 7 minus 2y plus 6y equals 12. Distribute my 3. 21 minus 6y plus 6y equals 12. I combine my like terms and, the y's go away. I'm left with 21 equals 12. This is a review of Unit 4. This is a false statement, so this gives me no solution. Okay, it's the same concept. Now, if I had subtracted everything away and I came up with something 3 equals 3, then that would be infinite solutions. But we do not have that situation here. It is just plain no solution on this one. Okay. That's about 15 minutes. We're going to stop on this one, and I'll finish up the rest on the next one.